All right, in this video, we're going to see a couple of examples using the average value of a function formula that we developed in the last video. So here's our formula. The average value of a function f is 1 over b minus a, that's 1 over the length of your interval from a to b, times the integral of the function itself from a to b. So relatively straightforward formula here. And we're being asked now to find the average value of the function f of x equals 1 plus x squared on the interval from -1 to 2. So let's plug in what we know into our formula here. A is going to be the first part of the interval here, the far left side. B is going to be the far right side. And then f of x is just the function 1 plus x squared. So we plug in everything that we know here. This becomes 1 over 2 minus -1 times the integral from -1 to 2 of our function 1 plus x squared dx. All right, 2 minus -1, that's plus a positive 1 is 3, so we get 1/3 on the outside. And then to integrate this function, again, we're just taking an antiderivative here, so we're going to use the power rule in reverse. Raise each power by 1 and divide by that resulting power. We are going to get the antiderivative of 1 is just going to be x, and the antiderivative of x squared will be x cubed over 3. And we're evaluating here between -1 and 2. Okay, so now we can plug each of our values in and see what we come up with here. We're going to get 1/3 times the quantity 2 plus 2 cubed over 3 minus, and now plug in -1, we get -1 plus -1 cubed over 3. All right, so now we got to simplify. 2 to the 3rd power is 8, so we're going to get 2 plus 8/3 here. And then here we have minus a -1, which is plus a positive 1. And -1 to the 3rd power is -1, so we get -1/3 here. And we're subtracting it, so minus -1/3 is plus a positive 1/3. Okay, so now 8/3 plus 1/3 is 9/3, or just 3. So then we have 2 plus 3 plus 1 is 6. So we get 1/3 times 6, which is precisely 2. Whew, there we go. So what we have learned is that the average value of the function f of x here equals 1 plus x squared is going to be equal to 2 on this interval. Let's see if we can understand this idea visually. If we graph this function, we can see exactly what this means. This is a nice simple quadratic, so we know basically what it looks like. It's going to be a parabola opening upward with its vertex at 0, 1. We're going to get something like this. Let's see. I'm going to need slightly more space than that. All right. So we have a parabola starting at the point 0, 1 here. There's the vertex and opening upward. So we get something like this. And of course it does continue on in both directions, but the important parts are between -1 and 2 for this problem. So we are looking at the values between -1 and 2. All right, and what we found is that the average value of this function here should be exactly 2. That means the average height, or the average y value, should be y equals 2. And so that you can see, ignore the stuff on the left, ignore the stuff that's further to the right than these orange values. If you look just between these orange values here, this yellow line should be the average height. And we can see that intuitively this makes some sense because most of this interval we have below the yellow line, but then we have the last single unit here jumps way up above. So this upper amount here is canceling out the lower amount to get an average right there. Okay, so there's the calculation, there's the intuition that goes along with it. This is the idea of the average value of a function. Let's try another example. We're going to change the function and change the interval. Let's look at the function f of x equals the sine of x on the interval from 0 to pi. Okay. Now we know basically what this graph looks like, right? The sine function starts off at 0, 0, increases up to 1, and then decreases back down to 0 by the time we get to pi here. So we are going to see something like this, where we've got pi, and then at the middle, pi over 2, which gets our function up to 1 here. So our goal is to find the average value of this function here, y equals the sine of x, on the interval from 0 to pi. Now, again, we're just going to plug straight into the formula to figure this out. We have to take 1 over b minus a, so that means we're going to take 1 over pi minus 0 times the integral from 0 to pi of our function, the sine of x dx. All right. Of course, pi minus 0 is just pi, so we have a constant 1 over pi on the outside. And then we are going to take the antiderivative of the sine function. This is going to give us the negative cosine function. We get negative cosine of x evaluated between 0 and pi. So when we plug in our endpoints and subtract, we are going to get 1 over pi times the value negative cosine of pi minus the negative cosine of 0. Okay, now the cosine of pi, we are looking on the left side of the unit circle now. This is going to be negative 1. So the negative cosine of pi is going to be positive 1. The cosine of 0 is positive 1. So when I subtract the negative cosine of 0, I'm going to get another positive 1 here. So negative cosine of pi minus negative cosine of 0 comes out to 2. And we divide the whole thing by pi. So the average value of this function will be exactly 2 over pi. And 2 over pi comes out to about 0.637, or right around here. Call that 2 over pi. So we're looking at right here to get the average value of this function. Again, my graph is approximate here, but again, you can see that most of the function here is above the line here that we came up with some smaller spots down below. So there should be some canceling out to give us that as our average value. Okay, so that's how we work on the average value of a function. In the next video, we're going to introduce one quick application of this idea, which is going to be called the mean value theorem for integrals.